Welcome to The Explainer. Today, we're diving deep into one of the most fundamental building blocks of, well, everything, the proton. But we're going to be looking at it through a completely new and, frankly, radical lens to see if a hidden geometric reality has been staring us in the face this whole time. You know, we all learn about the proton in school, right? It's the simple, stable little particle at the heart of every atom. But in standard physics, that simple picture just dissolves. It becomes this chaotic sea of quarks, antiquarks, and gluons, all flashing in and out of existence. So that begs a huge question. How does something so stable, so predictable, come out of all that chaos? Let's start with what we actually know for sure.
For decades, we've been running experiments that have pinned down the proton's properties with just incredible precision. Its charge, its spin, its mass, its size, these are constants we can set our watches by. And get this, the proton is unbelievably stable. Its lifetime is way longer than the current age of the universe. So again, how do these rock-solid traits come from that chaotic picture? The standard model doesn't really give us an intuitive feel for it.
Okay, so let's try to get a new perspective. For that, we need a new tool. We're going to use a framework called single-point theory, or SPT, and it has a wild idea at its core. What if particles and forces aren't things at all? What if they're actually geometric patterns, like stable whirlpools or vortices that emerge from a single underlying field? This right here is basically our Rosetta Stone. It translates the physics we all know into this new language of geometry. So suddenly, mass isn't stuff anymore. It's the energy density of a vortex. Charge isn't some property just tacked onto a particle. It's literally the direction that a vortex is winding. And forces? They aren't mysterious messengers, they're just gradients or slopes in the field itself. So with this new geometric language, can we build a proton from the ground up? Let's see how SPT tries to reconstruct this fundamental particle, not from a chaotic soup, but from stable, geometric first principles.
So instead of quarks and gluons, SPT starts with something it calls a resonant node. Basically a stable vortex in this process field, and its model for the proton is just stunningly elegant. It's a cluster of 3 of these little vortices braided together in this self-reinforcing, topologically locked-in pattern. That braid is the key. It's what gives the proton its incredible stability.
And this is where it all just clicks into place. The proton's core properties are no longer these mysterious add-ons. They're built right into its very geometry. The baryon number, the thing that makes it a proton, is literally the number of links in the braid. It's a topological fact. Its positive charge? That's just the net direction the vortices are winding. And its spin is simply the total angular momentum of the whole twisted structure. It's all geometry.
Okay, let's keep going. If particles are just patterns, what does that mean for the forces that hold the proton and, the entire universe together? What are the interactions between them?
In this geometric view, mass isn't stuff. It's really a measure of a pattern's persistence. These tightly wound, super-stable patterns like the proton's braid have a ton of energy locked inside them. And that's exactly what we measure as mass. Now this gives us an incredibly neat explanation for one of the most basic things in nature. A proton is positive because its vortices wind one way. An electron is negative because its vortex winds the opposite way. So attraction isn't some weird magic, it's just the geometric tendency for these opposite windings to overlap and cancel each other out, which lowers the total energy of the field. So here's the crucial point. In SPT, you don't need exchange particles like photons or gluons. The forces holding that proton's braid together are the geometry of the field itself. The particles, which are just vortices, simply move along gradients in the field, kind of like a marble rolling downhill. They're always trying to find the path of least resistance to minimize the total field energy. And this simple distinction lets SPT describe different forces as just different geometric features of the exact same field. A gradient in the field's amplitude, its energy density, is what we feel as gravity, and a twist or torsion in the field's phase is what we feel as electromagnetism. 2 fundamental forces, 1 unified geometric source.
Now, look, a beautiful idea is one thing, but for a theory to be actual science, it has to make unique predictions that you can test. So, how does this whole geometric model hold up against the hard data? Does it make any predictions we can go out and measure?
And that right there is the make or break question.
Turns out it does. One of its most powerful and unique predictions is something we can call a vacuum stiffness scaling law. It's basically about how the field geometry pushes back when you poke it. The theory says that the universe resists being distorted differently at different energy scales.
A low-energy poke sees a soft vacuum, but a high-energy poke sees a stiff one.
And the theory makes a very specific, very precise claim. It says that this effective stiffness scales directly with the energy of whatever you're using to measure it, raised to the power of 1.5. This isn't some vague statement, it's a hard number we can actually go and test.
And this is where it gets absolutely astonishing. When we take that scaling law and check it against high-precision atomic measurements, real-world experimental data, the results are a near-perfect match. We use one measurement to set the scale, and boom, it correctly predicts the result of a completely different one.
Just look at that. The prediction is off by less than 1%. That is not just a qualitative agreement. That is a stunningly precise, quantitative validation. This is powerful, data-driven evidence that suggests this geometric framework might actually be describing a deeper layer of reality. So let's just step back for a moment and think about the really profound implications of all this. If the proton is a geometric braid, and if forces are just the shape of a field, what does that mean for our whole understanding of reality itself?
When you see the proton through this SPT lens, it kind of suggests we need to shift our whole perspective. We've spent centuries asking, what is the universe made of? As if it were built from tiny little bricks. But this theory suggests a better question might be, what process is the universe running? It reframes reality not as a collection of static things, but as this dynamic, ongoing computation generated by a single, unified process of wave interference.
And that leaves us with a final, pretty provocative thought to chew on. If the most fundamental parts of our world, the particles in our bodies, the forces holding the stars together, if they're all just resonant, stable patterns in a universal field of interference, then what does that imply about the nature of reality itself? Are we all just patterns trying to maintain our stability within a cosmic process? Now that's a question worth thinking about.